Good morning. How are you? Assalamualaikum, everyone.
Salam, Prof.
Morning, Prof.
Morning. So let's see how many of us. Only 5 students come in. So we will wait a few minutes for the other students to come in. There should be 10 students. Okay, I think we can start. Okay, today we will cover a topic and actually in the book it should be, textbook, which is a very good part. In the textbook should be chapter 5 is about IT infrastructure. Yeah, but in our notes it's actually topic 4. In your your open learning, it should be open up open learning. No, open learning. Actually we cover IT infrastructure, information technology infrastructure. Why do we need to learn IT infrastructure? Some content on defining IT infrastructure. Yeah. How do we build an IT infrastructure? And then evaluation of IT infrastructure. So I'll show you the slide. The content is actually already up in the open learning. Some of the content, and then I will share this in your WhatsApp. In WhatsApp group, I will share this slide. Today we'll cover topic 4, IT infrastructure and databases. So what is IT infrastructure? Okay, IT infrastructure is actually like you see here, the shared technology resources that provide platform for firm-specific information system applications. Okay, information system is a combination of hardware, software, and different services and so on. So it is a system. It is a whole system. People, I think we discussed that last course, last class. And then the IT infrastructure is the shared technology resources, yeah, to provide that platform. So it is a set of physical devices as well as software required to operate an enterprise. When we mean enterprise, it means any sort of organization that run businesses. Yeah. And then this set of firm-wide services include the computing platform, which provides the computing services, the physical facilities, yeah, of management services of the computing platform, IT management, education, and other services. Yeah. Uh, I think this is okay. Continue. Make sure this is correct. Okay, and then when we look at service platform perspective, we are looking at more accurate view on the value of investment, specifically on the information system. Yeah, I need to move this. Okay, so there are connections. This is the connection between the IT infrastructure and business capabilities. Okay, when we develop our business, anybody when we run our business, we have on the topmost is the business strategy. Who designed the business strategy? Who developed the business strategy?
top management.
Okay, top management developed the business strategy, and then uh, the top management is at the strategic level management, and then the bottom of it, below it, there is we call a middle level management or tactical level management. This level management have functional uh, units like marketing, finance, and so on. And then one of it is the IT strategy, IT unit, IT department. Okay, each unit will have their own strategy. We have marketing strategy, we have finance strategy, we have production strategy. It is for tactical level. And then in the tactical level, we also have IT strategy. So coming down from the business strategy, we have an IT strategy. I think if you can recall, I mentioned to you, I think in the previous class, I need to, yeah, I need to put up a report. In the previous class, we mentioned that at the top level management, we have a top, we call it organizational goal. At the top is the organizational goal. And then below the organizational goal, we have these departmental goals or functional goals or departmental goals. We have many departments, and then each department have their own departmental goals. Yeah. So I just put some examples here. Maybe you have finance, we have production, you have IT. So these are each and one of these will lead to us achieving the main goal. Okay, like this is the means to an end. So the goal is to achieve the organizational goal. So every unit will have their own functional goals. So we have here, we should have IT strategy here. Assuming that this is the IT department, yeah? IT department, we have IT strategy, and the top is the overall business strategy of the organization. Yeah. So we know that from the business strategy, in order to achieve the business strategy, IT will have its strategy that ties up to the business strategy. What is the requirement of the whole business? The requirement of the whole business will depend on the other units as well, meaning that it should support the marketing, or finance and accounting. And then IT will have its own strategy. Because this business strategy here, usually you have your performance, profitability, And then you have your performance measurement, operational performance measurement, organizational performance. Yeah. So, and then the number of customers that you target by the marketing department. So from this, the IT strategy will develop its strategy here. So in line with the business strategy. Yeah, in line with the business strategy. So we go back here. So there is relationship between IT strategy and the business strategy. And then from the business strategy and from the IT strategy, we will maintain the IT department will maintain its information technology, the technology. When we refer to this, we refer to the technology here. The technology. What sort of technology do you want in the organization to support the IT strategy? What kind of hardware? What kind of software? The people. Yeah, we can check this IT system comprised of a lot of components, networking, and so on. So the IT infrastructure, and then from this, from the combination of IT strategy, business strategy, IT strategy, and information technology. Information technology is what technology we have at the moment outside there that supports our business. So we will combine all this to develop our IT services and infrastructure. What kind of services do we provide? What sort of infrastructure do we want? This IT infrastructure will provide the foundation towards serving the customer. Yeah, working with the vendors and providing internal firm business processes. We talked about business processes last week. Oh, last class. Yeah, so we have business processes that run by the enterprise. Within the enterprise, so what are the business processes? You need to be supported by the IT services, and then the infrastructure should be there. And then the supplier services, you have supply chain management, you have your business value chain, and then the customer service, marketing, sales, and after sales service need to be supported by the infrastructure and services. And then what kind of technology there are now? What is the strategy that we have? We achieve the strategy within there is a relationship here. Yeah. When you develop the strategy, we look into the technology and the tie up, and then the main thing we have here is the overall business strategy. And then there is a tie up between this business strategy and the IT strategy. And then there is also a relationship between this information technology and the business strategy. Okay. I think everybody by now should understand this. So this is the overall picture of how do you develop your IT services and infrastructure. Yeah. In order to support the customer, how do you work with vendor, and how do you have run your business processes. Yeah. The which derive from your business strategy, from your IT strategy, as well as the information technology, prevailing information technology that we have outside there. Maybe today we have big data, we have blockchain, we have intelligent systems or artificial intelligence, we have machine learning, deep learning, we have big data. What else? We have IoT. So it's the technology that we have outside there. Okay, any questions so far? Okay, as though everybody is okay, I think this is the basic thing that you need to understand. So what are the services provided by the IT infrastructure? It provides the computing platform. Computing platform, of course, this computing platform will require the hardware. But the goal of this computing platform is to provide computing services that connect the employees, customers, supplier into a coherent digital network environment. This is the situation that we have today, the definition that we have today. The computing services connects the employee, customers, and suppliers into a coherent digital environment. This is the information. This, um, it may be different in 1970s, it may be different in 80s, 90s, year 2000, but 2020 and onwards, or even year 2000 onwards, the computing platforms provide computing services that connect everybody, connect the employees, connect the customers, connect the suppliers into a coherent digital environment. So we have the enterprise services or enterprise resource planning that support the employees. We have the customer relationship management that supports the customers. We have the suppliers, yeah, which are supported by the uh, supply chain management system, and then we have other systems like knowledge management system, business intelligence, and then numerous other systems that are being supported with each other using over a coherent digital environment. Meaning that when you talk about coherent digital environment, you have these networking services. The networking services is part of the telecommunication services. There is convergence of data, voice, and video connectivity to form these telecommunication services. And then what do they provide? They provide data. We provide information. They provide knowledge. Data, information, and knowledge. So what do we need to provide this data, information, and knowledge? We have data management services. Yeah. So data management services store and manage the corporate data and provide capabilities for analyzing data. Yeah, so we have ERP that can analyze data, we have SEM, we have knowledge management system, we have business analytics that can analyze system. So the component of this data management services are data. Yeah, but we know that data actually we are comprised of data, we have information and knowledge. There is another level, we call it wisdom. We will uh, discuss about it in later topic. Yeah, we have a topic on. Uh, but the rudiment component, the basic component of knowledge, information is data. Data is the raw. So we'll cover this later. And then the services provided by this computing platform over the telecommunication services, applying this data management services is what we call application software services. Application software services are very broad. There are many application software services, but the main services are ERP, CRM, enterprise resource planning, customer relationship management, supply chain management, knowledge management services, and systems that provide these enterprise-wide capabilities. So they have these enterprise-wide capabilities. So these application software services are shared by all business units within the organization and even beyond the organization. We have the term here, we have the term intranet and extranet. Yeah, we have internet as is the main internet is a broad term. Internet, when you talk about internet, yeah, internet always use capital I. Internet is a specific name. Internet is a specific name. It is the internet that runs begin with ARPANET, develop, and then it is a specific network. It's called internet. But intranet and I, it can begin with I, small I, and small e. So intranet is the Network within the organization, that is intranet. Extranet is the network that go beyond the organization to other organization. For example, you have your vendor, you have your sales agents that have access towards your networking facility. They are called extranet. So within your organization, we call it intranet. Internet is the specific term for it's actually the internet. We will discuss about internet later, in later topic in networking. What is the internet? Yeah. And then besides this, you have physical facilities management services. Of course, when you have this computing platform, you have the telecommunication services, data management services, we have application. Everything will be placed in a physical installation. Yeah, so the physical facilities management services will develop and manage the physical installation required for computing, telecommunications, and data management services. On top of it, we have these application services. So this computing platform, telecommunication, and data management services are referred to as infrastructure. But on top of it, we have this application on top of the basic infrastructure. And then they are all placed in a physical facilities. Okay, the question is, where is the cloud? Everybody talking about cloud. Where is the cloud? Is the cloud a physical facility?
Non-physical, tapi it requires physical facilities as well.
It requires physical facility. Is it physical? Cloud?
The cloud is not physical.
Cloud is not physical. Any other answer?
Cloud is not physical for an organization. It's more like a service provided by another organization, which
Yes.
have physical to them.
Okay, cloud is physical actually, yeah, Alia. Cloud is physical, but it's actually it is a service. Okay, I'll share my screen. It depends who from which point you are looking at it.
Yeah.
Okay.
Like Wan just said, the customer doesn't see it, but the provider is physical.
Yeah, the provider is physical. So I will clear this. Okay, you have I need to draw something. Okay, we have this main server. This is the server. And then we have other users. And we have users. We have users. We have users. User 1, user 2, user 3, yeah. Users. Yeah. 1, you have user 2, you have user 3. They don't have this. They don't have the hardware facilities in their premise. They don't have the facilities, the physical facilities in their premises, but they access the computing over the internet. It has the capital I. Internet always capital I because it is a specific name. Okay. So they access the physical facilities in over the internet to another server. So for them, they look at it as they accessing the cloud, but it's actually a physical. There is a physical network. Yeah. For them, they say, okay, we are using the cloud, but actually there is the cloud is a physical network. We refer. Yeah, it is a physical network. Okay. Clear, everybody? Okay. 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 The history of cloud begins with actually Amazon. Who is this name? Who is this name of Amazon? I forgot. Yeah, Jeff Bezos. Yeah, Jeff Bezos of cloud. What is the business of Amazon before they have this Amazon Web Service?
Retail.
They do e-commerce, retail. And then when most at times they have access storage, they have access computing resources. So they start offering people to use their computing processors, CPU, they and then to use their database storage. So this access they charge for a fee. So they allow people to use and they charge for a fee. They call it pay per use. Yeah, the term is pay per use. And, then that is how cloud computing came into the picture because it's the physical those who have access of computing resources and database start offering services to other customers who are outside over the internet. Without the internet, there is no cloud. Okay. Besides these services, we have IT management services. They plan and develop the infrastructure, coordinate the business units, manage accounting for the IT expenditure, and so on. And then we have IT standard services. Standard is very important for IT so that we can talk to each other. There is no cat and dog talking with each other. So everybody have a standard to talk with each other, and then standard platform, standard policy. So there are IT standard services. We will go into detail the standard services. Among the prominent standard services are the ST, the uh, World Wide Web Consortium that develop standards for HTML, XML, and so on. And then besides that, we also have IT education services that provide training, yeah, in system used by employees. And then we have IT research and development services that, provide potential research on the potential future IT projects and investment. Okay. So any questions on this? There are 9 IT services provided by IT infrastructure, uh, computing platform, telecommunication services, data management services. Basically, these are the basic IT infrastructure, these three. And then on top of it, we have application software services, physical facilities management services, IT management services, standard services, education services, and IT research and development services. Any question?
Doctor, I have a question. Previously about the cloud computing. Previously in my previous company, we did try to migrate our accounting system, basically invoicing and stock system from the old software to cloud computing. We were trying, but at the time, I got one problem is just nice one day, the internet is down. So when the internet is down, because we are using the cloud system, the whole system doesn't work. Then like the whole day, we have a lot of problem. We cannot even print out the invoice and stuff. So it causes a lot of problem and end up our boss decided to dump the idea and go back to the old system. So in your opinion, is that a cloud failure or is it IT management or some problem in
Okay,
our
what IT management, your IT management is not cloud failure. Cloud requires you to connect to the internet, and then cloud doesn't guarantee that you have the internet. The one that guarantees you have the internet is your telecommunication infrastructure. Your telecommunication infrastructure. So how? And then the telecommunication infrastructure, if you ask them, they will provide 99.9%. You can go to time. We deal with time in UPM. We deal with time. Yeah, time complete time TIME time. So and then you have telecom. They ask when you ask them their service level agreement SLA. Usually they state 99.9%. What does it mean by 99.9%? Meaning that there is 0.01% that you don't get the internet. Right.
how do we counter in that case of the internet down, which it causes a lot of problem? The one
Okay.
whole day, the backlog, everything, the business loss is quite drastic actually.
You need to have a safety net by having another platform. But if you subscribe to two platforms, it will be costly to you. It will be costly to you. One way is actually this is not just my loud thinking. One of your system should subscribe to another platform, another network. One, for example, you have nine company, or it's actually or nine departments, or say 7 or 8 departments subscribe to the main provider, telecommunication provider. You have one or two that subscribe to another provider, so that when there is a situation for that situation, you link out to another the other platform provider. For example, you have telecom and time. Yeah, but don't subscribe to the same group. For example, you get Maxis and Maxis fiber network and Unify. Who is the provider, the main provider of Unify?
TM.
TM. Who is the main provider to Maxis fiber network? TM also. So if TM down, both down. So you can opt for another one. That is your fallback position. That is how you can readjust your network because you have your local area network. So your technical guy can uh, link it out using the different provider. In simple layman terms, don't put all eggs in one basket. Does that answer you, Deepo?
Yes. That means actually ultimately we have reached a era where internet is as important as electricity.
Yeah.
We,
Yeah.
we
Yeah,
can't do anything about it.
But also, Guanji, there's also like even our Google Workspace, they have the capability to work offline as well. So find a system that actually has an offline capability, tapi when you want to do only the uploading and downloading, only then you use the cloud.
Okay, there are systems that have offline capabilities. There are systems that have offline capability, but they will require some part of your storage.
Yeah, correct.
They require some part of your storage, not totally cloud, not totally online. There are systems that you need to download, but not complete. Usually it is not complete. Usually it is just an API. We call it application programming interface. And then this application programming interface, it will not be able to access all services. Will not be able to access all services, but you during the period of time, you can do some basic work, and then it will be updated once you get back to the internet. That is another option, yeah. Okay, now we look into the stages of IT infrastructure evolution. The mainframe came into picture in 1959. Then we have personal computer in 1981 and above, and then we have client server. We have today. Mainframe still there until today, and then this is client server era, and then we have enterprise computing. We have cloud computing today. There are issues in cloud computing, so we'll go in detail later. But I want to ask you, have uh, uh, is there? Are you aware that computing doesn't begin electronic immediately or electrical immediately? There was a mechanical computer. Yeah. Jipo,
Yes.
what was it?
Pardon?
In a mechanical computer?
I haven't seen, but I read before.
Okay. The first computer was developed by a person named Babbage, Babbage. Yeah? So I have a video. We'll share a video on an electronic, mechanical computer.
The one with a lot of hole on the card.
It is mechanical. It is really mechanical. Okay, I'll share the screen. It's a short, few minutes video. I think about 5 minutes something. I need to share the sound.
Charles Babbage was the only child of a tyrannical London. In 1832, the drawing room of his London home became a showcase for demonstrations of a small section of his difference engine, a far from finished device by which he intended to revolutionize calculation by mechanizing it. At his soirees, London's intellectual society watched what you see now. As Babbage cranked its handle, this machine produced a series of polynomial calculations that were repeatable and error-free. Most astonishing, it was automatic. Any of his illustrious guests might have operated the handle as well as Charles Babbage, perhaps the geologist Charles Lyell, or Charles Darwin, or Charles Dickens. Once set, the machine seemed able to proceed, to think on its own. But what was called the beautiful fragment of the machine Babbage breakthrough, elegantly drawn up, annotated to describe mechanical motions with a coding system that Babbage claimed was his finest invention. The analytical engine may be the most intricate operating mechanism ever fully realized with paper and imagination alone. In 1846, Babbage abruptly changed course. More than 130 years later, in 1985, the museum's new curator of computing, Doran Swade, became convinced the institution could build difference engine number 2. After all, with the intact drawings, it seemed feasible and within financial reach. It took 17 years and drama to rival Babbage's so long ago. And it works, just as Babbage designed it. Every turn of the engine's driving handle is carried through gears, cams, rods, levers, and springs to release and arrest precisely aligned number wheels. A helical arrangement of steel fingers continually pulls the register towers to find and perform the carrying of tens. In its continuing sweep upward, it is mesmerizing. The intricate printing section can be programmed for 1, 2, or 3 column output, for 2 font sizes at once, for variable margins and column gaps, even word wrap where necessary. It prints hard copy on paper and simultaneously impresses the same output into a tray of plaster to produce a stereotype, a mold for casting a full-page printing plate. When a tray is full, the printer pauses the entire machine. In the spring of 2008, a clone of DE2 commissioned by Nathan Myhrvold was completed at the Science Museum and shipped to California. At the Computer History Museum, it would charm new thousands of discerning eyes. Today, the crotchety proud genius, who never managed to prove it during his lifetime, has a fair claim to honor as a pioneer in the history of intelligent machines, just as his parlor guests in 1832 suggested. His difference engine continues to inspire the admiration of his intellectual heirs, a celebrated and unique icon to chroniclers of computing. Charles Babbage, remember, never saw it, except in his stubborn, prescient dreams.
Doctor,
Doctor, you're on mute.
Okay, the one that you said holes, Jiko, is actually that is what we call punch cards. Punch cards are not mechanical. Punch cards are electronic. the computers are now has became electronic. So why do they use punch cards? Because that time we don't have keyboards. Before the advent of keyboards, before you took for granted that you have keyboards now that you can key in. Before we have keyboards, they need to put inputs in form of punch cards. So and then I'll show you another video. This is on the when computers become electronics. The we call it first computer, but this is an electronic computer, electrical computer. Be specific, not electronic. When you talk about electrical, meaning that it is big. Yeah.
At the Moore School of Electrical Engineering at the University of Pennsylvania, they were very, very strong in computation because there were engineers back then who were moving more toward not just how you do things based on what people did before, but to break new frontiers. And as they did that, the mathematical complications became difficult to solve. So they needed a machine. So they decided electrons are faster, we'll move them through these tubes, and we'll click them on and off, and we'll make a machine that would solve these equations. They created the world's first all-electronic, general-purpose digital computer. When the war started, they were picked especially to do computations for the Army for long guns and firing tables.
ENIAC was revolutionary in being the first large-scale general-purpose electronic digital computer ever built and led to the evolution towards modern computer technology by developing the stored program architecture that is the fundamental architecture for all computers today.
They solved these equations that they thought would take 2 years in 2 hours. They did it. So the world changed.
You know, without ENIAC and the University of Pennsylvania and the city of Philadelphia, we wouldn't have Google, we wouldn't have Microsoft, we wouldn't have, you know, the things that are driving today's economy and the rapid innovation that keep happening in computer devices.
People just create things even if they're not being prompted to. That's what human beings are about.
You need new knowledge to start something new in the marketplace. So people create knowledge. Knowledge is inherently human.
Okay, that is the electronic computers beginning, and then in my PowerPoint, open learning. Let me open the open learning. In the open learning, I describe the evolution of computers. Okay, this is the within the beginning from 1959, 1965, 1959, IBM developed this IBM 360 series, which was the first commercial computer. Yeah, you can see this time. You look at IBM 7090, we have punch cards here. They don't have this like Jipo asked just now. We have holes in the cards so that you can put in the cards. So the computer can process it. We don't have keyboard yet at the time. This is mainframe computers, 1965. DEC is Digital Equipment Corporation. I think DEC exists until 1999, 1996, 97, until it is being acquired by Compaq Computer, and then Compaq Computer was acquired by HP today. HP begins with printers, and then they acquired Compaq. Compaq was the first IBM compatible computer, or we call it clone, IBM clones. And then it acquires DEC, digital computer. DEC was the first one that developed this alpha computer, alpha server. This is DEC, PDP-1, DEC BAX. And then in 1981, there is advent of Apple I and Apple II. This is Xerox Alto. Xerox merged. Today, Xerox merged with Fuji, become Fuji Xerox. Before that, this is Xerox. Xerox is the first company that developed this GUI, graphic user interface, where it was copied by Apple. And then this is Altair. This is Apple I. This is Apple II. Actually, the first computer that I used personally, the first computer that I used was Apple II. I used Apple II in 1979. Actually, the first computer that I used. Before that, this is Apple I. And then IBM also have their PC. Yeah. And then Microsoft Lisa. Yeah, I have this. And then this Microsoft is IBM PC. Before that, every computers have their own operating system until I think until Bill Gates acquired Microsoft MS-DOS. Bill Gates did not develop MS-DOS. Bill Gates purchased MS-DOS from someone else, and then extended it or supplied it to IBM. And then we have, before that, IBM have their own operating system. Lisa is the first computer that have GUI. It actually was copied from Xerox. The GUI stands for graphic user interface. And then this is Sinclair. Sinclair ZX. Sinclair is they sell it like this, so you connect it to your TV, to your television set, and then you can see television set. But that time, television set not digital. We have string, so it's not very clear. This is Apple Mac. And then in 1983 onwards, we have this development of ARPANET. ARPANET, which today becomes this internet. So with that, we have client server computing. Client server computing, where we have server linked to clients. At this time, the clients are using not PC, they are using thin clients or dumb terminal. Dumb terminals. It's actually just a basic unit. It's not a PC. It's actually dumb terminals, or we call it thin clients. So the clients are connected to internet connected to the web server. Example web server here. Today we have Apache or IIS or Unix or yeah, and then we have application server where you place your application database. And then Tim Berners-Lee, scientist in CERN, okay, currently Professor Tim Berners-Lee, if I'm not mistaken, work with Southampton University in UK to develop this TCP/IP. This TCP/IP run on top of the internet. Internet and World Wide Web are two different things. So internet was created later after the World Wide Web was created later after the internet. So that we have this enterprise computing era, and then we have cloud and mobile computing on after that. This is we can watch this later. This is a Apple Lisa commercial. Yeah. Stop share. We go back to our slide. PowerPoint. Okay, so that is the mainframe, yeah, and then we have personal computers, we have client server, and then Then we have, this is a multi-tiered end tier, I showed you just now. And then we have enterprise computing today, and then cloud computing. Cloud computing, like I mentioned to you, we have a server in the middle, and then all the other hardwares are linked, connected to the server. Because you can have a basic hardware, for example, like a thin client or a laptop or tablets connected to the cloud, and then you can actually all the processing are done at the client at the cloud computing. There are several technology drivers that motivate or drive this infrastructure evolution. Okay, according to Gordon Moore, he wrote in Electronics magazine, the power of microprocessor, the processor that you use in the CPU doubles every 18 months, and then computing power doubles every 18 months, and then computing price of computing also falls half for everything for every 18 months. In terms of hardware, it's 18 months. You can see that the millions of processing processing line increase, number of transistors increase, and the cost reduce. And then now even chip computers shrink down their transistors into nanotechnology. We have chips today. We have nanotubes. And then the storage increase, and then it's cheaper now. We have storage is cheaper, and then networking with the internet, the networking connections increase very high. Yeah, this is by 1997. Today is much higher. And then declining cost of the internet. For example, when I first subscribed the internet, it was 2.5 cents per minute. 2.5 cents Malaysian cents per minute. Now you can subscribe a few months, less than 100. You have connectivity for the full month, unlimited. And then also the development of standards and network technology standards, development of standards. We have standards that we have today, ASCII. Before that, we have also, there is another European standard, but most prominent standard we have today is ASCII, the American Standard Code for Information Interchange. This is the standard that you use on your keyboard that link to your machine language in your computer. And then standard that is being used in banking, common and business oriented language, common business oriented language, COBOL. Until today, the banks still use COBOL. Unix, from Unix, we have it's a standard that being used to develop Mac and iOS, and as well as Linux and Android. Okay, so we can see that, say for example, Unix is a very important standard. Yeah, from for example, we have Unix here. Unix is a server language, server operating system. From Unix, we have Mac. From Mac today, we have iOS. Yeah, so from Unix we have. Okay, from Unix we have Mac. From Mac we develop into iOS. iOS is being used in the iPhone today. Yeah, so yeah, Unix. Yeah, Mac OS. The Mac is an OS, operating system. And then from Unix also we have Linux. Then we have the name of the person is Linux. Linux, and we have FreeBSD. And then Linux, there are two types of Linux, Debian, a few types, Debian and Red Hat based. For previous previously they developed into a lot of networking networking operating system. From Linux today, we have Android coming from Linux. Everybody heard of Android? Android is part of Linux. Yeah. So this is how the evolution of Unix. Unix is a standard. Go back to this slide. And then we have transmission control protocol, internet protocol that developed by actually two sides. Actually, one the main person is Tim Berners-Lee. Then we created this internet, and then we have Ethernet, which is the local area network standard, and then we have IBM, Microsoft, Intel personal computing. The thing that we have today, it begins with IBM personal computing. After we have this Apple computing as personal computing, Apple personal computing or microcomputers. IBM also developed theirs, and then from IBM they created, some people call it clone computing, IBM clone, some call it IBM compatible. The first IBM compatible was Compact, and then Compact, and then after Compact there are several other computers like developed based on IBM standard, like digital gateway, a few more that some of them doesn't exist anymore today. And then Compact was acquired. Compact acquired digital DEC computing, and then HP acquired Compact. Another standard is World Wide Web Consortium, W3C. You can, if you visit www or w3c.org, there is a site that you can see all these standards developed by World Wide Web Consortium. Okay. Any question before we move on? Okay, we move on. Okay, components of IT infrastructure. These are the 9 components of IT infrastructure. We have a computer hardware platform. We talked about the hardware just now. We have this operating system platform. We have enterprise software application. We have data management and storage, networking and telecommunications platform, internet platform, and also the consulting and system integration services, SI. Okay, we go one by one. Okay, when we want to develop an IT, this is the basic components and 9 components. We have hardware, operating system, software application, networking, system integration, data management, and internet platform. Example here, for example, computing hardware platform is the Dell, IBM. We have many more today. And then we have operating system platform. We have open standards like Unix, Linux, and then you also have Android, and then we have also the one that provided by Microsoft Windows 10 today, and we have iOS by Mac OS, and then we have enterprise software application, SAP, Oracle, and so on. So go one by one. These are the client machines. There are two types of computer hardware. We have client machines. Client machine comprised of this desktop, PC, laptops, and then we also have these mobile computing devices, smartphone and tablets. And then we have this, there are 2 types of chips. For the hardware, we have their chips, and then for the mobile, they have their own chips, different chips. And then these are the servers. You can see this is a rack server. The leftmost is the rack server. In the middle, this is a tower server. And then this is a blade server. You slot the blade. Yeah, this is a blade server. This is a mainframe. Mainframe have not disappeared. It's still being used in banking and telecommunications network. This is huge mainframes. And then we have operating platform. There are two types of system. Yeah? Two types of software. We have this system software and application software. Yeah, I'll do that. Yours. Oh well, I use the whiteboard. There are two types of software. We have this software. We have a system software. And then we have application software. So, when you system software and application software. Okay, and then when okay, and then system software are broken up into two. We have operating system. Like I mentioned to you just now, Unix, Linux, those of Mac, or those are the operating system. We have utility systems. Utility systems is the system that manage the utilities in your the parts in your computer, manage the hardware components of your computer. Okay, the system software manage your hardware. System software manage your hardware because hardware are just the physical things, but it is managed by the system software. And then you have application software. Application software is all the rest. You can develop any other application software. Okay, I provide some in my I'll provide it in my open learning. Okay, you have read this. These are the latest update on the network standards. There, I give you some paper on Gordon Moore, the actual paper by Gordon Moore. You can read this in your open learning. The actual paper by Gordon Moore. And then this is the computer. Okay. Computer hardware. These are the components of the computer hardware that I mentioned to you just now. We have a central processing unit. We have input devices. We have output devices. Yeah. Like Jipo just asked just now. Before we even have the keyboard, we use the punch cards. Yeah. And then we have output software, and then we have primary storage, which is the RAM, random access memory, and also this read-only memory. Secondary storage is your other drives, CD and so on. And then you have communication devices. This is the operating system platform. There are two types: system software and comprised of operating system, utility software, and middleware. Middleware that connects between one system to another system, and application software. These are the system software. Okay, okay. These are the application software. We'll move into application software later. Okay, these are examples of operating system. We have Red Hat, Unix, Linux. This is Ubuntu. The brown. Do you see my mouse? Okay, this is Ubuntu, Windows 10, Mac OS. This is Android, Google Chrome OS, iOS. And then we have enterprise software applications that provide your CRM, SCM, supply chain management, customer relationship management, ERP. And then we have middleware providers. Then there is data management and storage software. For example, IBM DB2, Oracle, Microsoft SQL Server, SQL Server sometimes people call it, Sybase, MySQL. Microsoft have their MS SQL. For big data, we have Hadoop. Then we have a physical data storage, EMC squared. And then also we have the network operating system that manage the runs and network. We have an open source, FreeBSD. Besides that, we also have Windows Server, Linux, Unix, and then Cisco. This is the hardware provider, Cisco, Juniper, Tricom, and then also the telecommunication services, Telecom. In Malaysia, we have TM, Telecom Malaysia, we have Time, we have Maxis. They provide voice line as well as internet access. And then we have internet platform provided that provides the web hosting services, routers, cabling, hardware, server market, and the web development tools. Okay. And then we have consulting and system integration services, because at times not all companies have all the resources to develop their own system or integrate their own system. You require consulting companies, and you also require system integration companies, SI. And then there are systems that still run on legacy system. TPS stands for Transaction Processing System, TPS, Transaction Processing System. So the current trend in computing hardware platform, we have moved into towards more mobile digital platform, which are alternative to PCs and larger computers. We have smartphone, netbooks, tablet computers, digital ebooks, Kindle, and then there are wearable devices, goggles, and so on. And then there is also consumerization of IT and bring your own device, where you use your own devices in your office work. For example, you use your smartphone, tablet computers, but they install system and applications. And then there is quantum computing that use quantum physics to represent and operate on data. So it increases the computing speed and better processing power. And then virtualization. Virtualization is where you have a physical hardware, but you can break it, one physical hardware, and then you can break it into multiple hardware. Let's see. Let's draw. Okay, for example, you have one server. This is one server. Then you virtualize it into two servers. So this is how you can, this is called virtualization. A lot of cloud services provide virtualization. So you have server 1, server 2, server 3. Yeah. Okay, these servers are virtual, meaning that there is no physical server. The physical server is here. This is the physical server. So from one server, you're link to, they created 3 servers. Physically, there are only one server, but virtualized. So it reduced the hardware and power expenditure because there is only one server actually. And then it facilitates the hardware centralization. And then they do centralized defined storage, software defined storage, because there is a software inside here that break it out. They have a software. Okay. Any question on virtualization? Okay, everybody is aware of it. That's how cloud computing is created. by virtualization, you see that you have your own connection. For example, even web hosting, you have this virtual private server when you do web hosting, but actually you are sharing server with other people.
Doctor, sorry, server, is it just data storage, or it does has computing power?
Okay, there are server is a system that service that provides service. Server is a system that provides service. So what does it mean provide service? It can be hardware, it can be software, it can provide web server to provide your web, data server, database server provide data. So server is a general term as long as it provides service. So when how does it come into picture when they created this client server system? So there is a client, there is a server. This server can be anything. Network server, there is a network server that provide network. They provide network service. We have database server that provide database management service. We have web server that provide. So anything can be a server as long as it provide the service. So it can be, for example, Apache is a server, it's a software. If you buy a server hardware, also it's a server. Dell sells a server, it's a physical server. The server provides service. Actually, the name server derived from the term service. It serves something. Okay. Any other question?
Sorry, one more question. Back to the component of IT infrastructure. What's the difference between networking and the internet platform?
Okay, networking and internet platform. Okay, before we have internet platform, we already have networking. Networking is how we connect two or more computers. When you connect two or more computers, we call networking. So, and then there are many years that we have networking until the advent of ARPANET. They created ARPANET. ARPA is actually the advanced research project by the Department of Defense US. They created the ARPANET. And then I think I don't recall, but it's in my notes that they they decommissioned the ARPANET and then convert it into commercial and public use. We call it internet. Internet with capital I. Internet is a huge networking system. Internet is a huge networking system. So if you draw uh, wait, no. If you draw, I want to put up a whiteboard. Okay. No, not this. Stop share. Share. Okay, so I clear this first. So we have, I think everyone knows about how to draw a Venn diagram. I'll show a Venn diagram. Okay, we have, say we have networking. This is Venn diagram for networking. There are many forms of networking. And then in the networking, we have internet. Internet is a networking system. Okay, internet. With capital I, because it's specific name. Internet is a networking system. Yeah, so internet is a networking system. Network system. Internet is a network system. It is a network system. It's a huge network system. The largest network system is internet. Besides networking, we have local area network. Besides internet, we have local area network, wireless network, but internet is one specific system. Okay. Okay. Any is clear?
Yes.
Yeah, Jipo. Okay. Then we have cloud computing. Cloud computing, there are several forms of cloud computing. We have data as a service and so on. But basic three cloud computing systems are infrastructure as a service. Infrastructure service comprise of the processing service and then this networking service as well as the database service, data management service. That is infrastructure as a service, IaaS. And then besides IaaS, we have software as a service. Any application that you use, for example, SEM, supply chain management, ERP, they can be provided as a software. We call it SaaS. And then you can combine the infrastructure and platform to provide software platform as a service. For example, when you want to develop your own e-commerce platform, you don't have to buy your own server. You just use the server provided by Magento or Shopify, not Shopee, Shopify. And then they will include their infrastructure, they will include their software, everything together. We call it platform as a service. They provide the whole platform. So the cloud system can be private or public cloud. Public cloud it is open to public, for example, Amazon, open to public. Private cloud, you have a specific cloud that is is meant for your own organization. So with cloud companies can minimize their IT investment, but the drawbacks in cloud computing is constant security, but not specifically in terms of technical security, but more towards the I think we have discussed before, more towards this policy and regulation. Yeah, because we we need to know where the server is located. If the server is located in a foreign country, the government of that country will have access to your data because it falls back to the law of the land. And then there are also hybrid cloud computing models that combine the public and private cloud. You have certain public cloud, certain components which are private cloud. We call it hybrid cloud computing. So these are the infrastructure services, infrastructure as a service, with the computing resources management. You have your CPU here. We have network management. We have storage. Yeah. And then that is the infrastructure. And then we have this content management, enterprise software, collaboration environment, process management. This is your SaaS, software as a service. And then you can combine this infrastructure and also qualification to provide the platform as a service. We combine the content server, for example, you have content management, and then you have the storage management, you have content server, identity management, communications network, and block storage, and then the other devices outside. This is an example of services provided by Amazon Web Service. They do analytics, computing, networking, content delivery. Then there are this trend today, we have green computing. It's more towards reducing the power consumption, and we have data center so that not everybody is required to have their own server in-house, in premise, can use the data center. We can have data warehouse. There will be a topic on that specifically. And then we require high performance computing or power saving processor. They have multi-core processor. We have double two core, and so on, double core. And then we have power efficient microprocessor. Then there is a trend also to move into Linux and open source computing, so everybody can see the codes. And then there are also software for the web. We have Java, HTML, HTML5. HTML5 are more standardized compared to HTML, because HTML are prone to browser specifications. Some browser you will see different things, but HTML5 are more standardized. And then we have Java virtual machine, where you can, because it is what we call interoperability or portability. So we can, if you use a specific server, the server runs on Linux, for example, and then if you code Java in Linux machine or you code Java in Windows machine, you will see differently. But when you use Java virtual machine, you can code the same using different platform. So we have web browser, the Chrome, all these things are web browser, Firefox, and then we have HTML, HTML5, and Ruby, Python, and several scripting language, including PHP scripting language. And then I think before we move into web service, is there any question? Because web service, you need to go into detail. Are there any questions? Everybody can follow? Alia?
So yeah, Doctor, just when the previous details on all the types and the examples, we need to memorize them, or we just need to understand the type.
Okay, in your examination, normally your examination, they will ask you the when you specific question, and then you have to answer the specific term. For example, what is it? Operating system, and then you have to elaborate what is an operating system, and then you have to provide some example.
Okay,
Yes.
understood.
So you don't have to memorize all, but you need to know some example. So that you have this the main answer, the
Okay.
elaboration of it, and some example. So you need to memorize some of it. Okay, Alia?
Okay, understood.
Okay. So I think now it's 10:25. We will take a break of, let's say, 20 minutes. We give a break of 20 minutes. Okay, we'll come back at 10:45. Okay, please write your name and matrix number. I think, okay, we can continue. Okay, just now, when you talk about enterprise software applications, I miss out these points on is available in my open learning. These are the several enterprise applications that is applicable for corporates or enterprises or businesses. We have supply chain management system that covers from the sales marketing, cross-functional. It is cross-functional. Sales marketing, production, finance and accounting, across the middle, and also some operational management. And then we have in the middle, we have this knowledge management system, enterprise system that within the organization, because supply chain management and customer relationship management is actually extend towards is outside of the organization. We will have intranet and extranet. Okay, go back to our slide. This is enterprise software application. Okay, we move into Web service. What is a web service? Web service provide services to the. It's actually it's not a service to the customer or service to the vendor or service to the specific unit. It is a service to another computer. Web service is a service to another computer running through the web. So usually it is business oriented. So you want to deliver service. You actually begins with the server. Server provides service to another computer, intranet or extranet, and then they provide some application similar like API, closely related with API. API is application programming interface, so it runs over a service-oriented architecture. So the communication between the computer to another computer is usually over an XML. XML is extensible markup language, similar like it is similar like HTML. HTML is the language that you use on your browser over the internet. But extensible markup language is to communicate between one computer to another computer. It uses standard schema or so that one computer can talk with another computer. So they apply what we call service-oriented architecture. Service-oriented architecture is a set of self-contained services that communicate with one another to create a working software application. So this software developer can use services in combination or combine it to assemble it to use another to have another application. For example, this is how to illustrate web services. In your server of say the company is dollar and a car system, you have a legacy reservation system. Now you want to provide this legacy reservation system to other companies. For example, there is an airline company that want to book this car. For example, we also have the same situation with AirAsia. You can book cars, rental using AirAsia. So, but you need to have access to the server, to the system here. This web service provide connectivity so that you can communicate. We call it seamlessly. Same goes to with the tour operator system. You can communicate with this legacy reservation system. Travel reservation system can communicate with legacy. So it is not just mainly just having a hyperlink, but you can actually integrate with the database here, and then you can opt some of the services provided by the system, capabilities of the system, and then you can combine with your own application, your own system. So and then you can also use other web services from other companies or enterprises to put in together. Okay, that is basic about web services. Okay, any question on web services? Because most of the time it's difficult, it's not also easy, difficult for the student to understand. Web services is providing services through the web from computer with another computer. So you can have an application, extension of this application. You have this application, for example, legacy reservation system. You extend it to another computers in the Southwest Airlines, for example, or South Operator system. So the architecture that's the system that supports this communication is called web services. In the web services, they use the language that they use to communicate between one to another computer is called XML. It is a language, extensible markup language. Computers talk with another computer. So the customer will be here. The customer will be here. So the customer will access Southwest Airlines, and then Southwest Airlines will be able to deliver services back to the customer. So with this web service, they can also provide link to directly to this legacy reservation system, but not going directly. It's actually going through. I need to do this. They will be going through this XML service to connect to the server connect to the legacy reservation system. So the customer can book, can make reservation. Yeah. Reservations of their car rental. Yeah, on car rental. Using this system at their airlines company or at the tour operator or at the travel reservation system, because there is a web service here that link directly link through the web link to the server. This architecture is, we call it service oriented architecture. We call it SOA. Okay. Everybody clear? Any questions? Jipo, okay? Najwa, Habibah, Norasmin, okay? Okay. Okay, everybody is clear. Alia, okay, Alia?
Okay.
Okay, so this is service oriented architecture. Okay, I clear this. Clear the drawing. Okay. So the other the current other trend of computing software platform, we have software outsourcing and cloud services. I think we discussed about cloud services. Software outsourcing is we provide also cloud or other services that we subscribe. So there are service level agreement, and then we have mashups. Mashups is combination of a few apps. We have mashups. Apps is usually meant for mobile system. And then when you deal with computing infrastructure and platform, we look into the scalability, because some company may start small and then it will grow, and then you should be able to do to scalable. And then you need to have some policies and procedures how to deal with mobile computing and cloud computing. And then you have to look into the governance issues, who control the IT infrastructure, whether it should be centralized or decentralized. You may have different business units who can make their own decisions, so you need to be decentralized, or the central IT department makes the whole decision and then it should be centralized. And then another issue is you look into whether you want to rent the system or buy the system, whether you want to do cloud computing, you look into the security requirements. Basically, the technical, there are not many technical issues in cloud computing, but more of regulatory issues. And then outsourcing software, and then total cost of ownership. Total cost of ownership is the total cost of consuming the system from the day you acquire the system until the end, after when you what do you call it, terminate the system or sell off the system. So it comprises of hardware, software, including installation, training, support, maintenance, infrastructure, downtime, space, energy. But usually the hardware and software only account 20%. The rest, 80% will be on the training, support, maintenance. The total cost of ownership can be reduced when you use cloud services, but bear in mind when the cloud services are in, because there are issues when recently, when you look into, you use cloud, but how come the cost is high? That is because when you use foreign cloud, international cloud, there is an exchange rate. For example, one US dollar is 4.2 ringgit, for example. So whenever you buy $1, it's actually 4.2 ringgit. You multiply by multiply by 4. Something that costs 16 million here can actually cost 70 million when you convert it into foreign currency. So that is where sometimes when you really look at it in terms of you calculate it properly, sometimes the total cost of ownership for cloud services is not reduced. It is reduced if you use the local services, but if you have exchange rate and so on, it might be similar or much more higher. So how do you develop your IT infrastructure investment? How do you develop your IT infrastructure? So when you want to develop your IT infrastructure, the first thing you need to look is the market demand for the customer services, supplier services, and enterprise services. So you understand the market demand first. Yes, after you have looked at the market demand, you look into the firm business strategy like we discussed at the beginning of the class. You look into the business strategy. Yeah, I need to erase this. Yeah, you need to look into the business strategy. From the business strategy, you determine your IT strategy. What is your firm's IT strategy? And then you look into the information technology that we have today that fit to your needs. And then you will develop your, you will look into you will look into what is the, you will have some basic, what do you call it, preliminary IT infrastructure that you can propose, and then you can compare with what your competitors have. After you have compared all, you look into your business strategy, requirements, or the information technology, then only you can provide the, you also look into the infrastructure, infrastructure. So you will develop your own IT, propose your firm's IT services and infrastructure. Okay, this is the 6 steps. You look into market demand of your firm customer service, supplier service, enterprise service, and then you look into your business strategy, and then what is your firm's IT strategy, what is the infrastructure, what is the cost that you expected, and then information technology that you have, your competitors firm and IT services, your competitors firm IT infrastructure investment, how much they spend, then you develop your firm's IT services and infrastructure. Okay. Any question so far? So you have covered the topic of IT infrastructure. Yeah.
I have a question.
Yes.
In the case of Malaysian setting, like Malaysian environment, because I read in the paper that currently we are trying to provide a 5G network. So how exactly does this 5G network work, and what exactly actually are we trying to build here? Is it like building a new infrastructure, or is it like a new line or a new network facility? What is it actually, Prof?
Okay, 5G network similar like when you go to second generation, third generation, fourth generation. It increases the bandwidth. It increases the bandwidth. When you increase the bandwidth, what do you get when you increase the bandwidth? You can get uh, more detail actually. For every connection, you can send more size, larger size data, larger data size. Every connection you have larger data size. So previously, for example, in the beginning when we start, okay, the 5G is for mobile. For mobile, it is a cellular network. So we'll cover that in the networking. But anyway, I will answer you. It is a cellular network. Cellular network, it begins with before that we have before GSM we have ETAC, and then we have GSM, and then before that we have ATO. It begins just sending, communicating a voice, and then we move into communicating data, and then we have what you call a reborn voice. Reborn voice meaning that it convert your voice into digital and then send it over digital network, and then it reborn. Yeah, so you listen to a voice actually recreated by the computer. This is reborn voice. So it's larger, and then you start communicating using video. Yeah, want to have video communication. Today we can have WhatsApp, we can have video WhatsApp, and then we send videos, and not just for communication in video files. We send video files. So the requirement for bandwidth getting bigger and bigger. You need to get bigger and bigger so you can have clarity. So you can start watching video in small network, for example, like in your uh, this uh, mobile phone, but you want to watch it over mobile, but you can see it over a large screen TV, for example. You require a huge bandwidth. So how do you do that? You require a larger bandwidth. In order to have larger bandwidth, that's why we have this 5G. You can have, but it can be beyond video. You can send more detailed data. But one thing about when you move upper from 2G, 3G, 4G, 5G, the footprint gets smaller and smaller. The footprint gets smaller and smaller. So for 5G, the connection will be from for example, one electric pole to another electric pole only. So it will require investment of infrastructure. Yeah, so that because it will be because you need, so for every radio base station RBS, so you need to connect. It should be the access point should be in electric pole to another electric pole. So it's very small, the footprint. But you can always toggle. For example, when you over your cellular, you can move from 1G from 2 yeah, H to H to 4G. You can move to 5G depending on your needs.
So how does fiber optic cable is fiber optic cable plays an important part in it?
Yes, fiber optic cable will be the main infrastructure because the trunk line should be fiber optic or something that is that can deliver a broadband.
But I don't get what I don't get is there was like, because we have to connect one fiber optic to from contoh from a provider in another country into our country. Yang tu I tak faham. Why are you connecting to another country?
Yes, because that is the internet. The internet is a network. The internet is a network. Everybody is connected to each other. So you have line, for example, T1 from another country. For example, you have T1 here. T1 to T2 to T3, say to T1, very broadband, this is main trunk connecting from one country to another country. And then you have connection here, and then you have a fiber, maybe you have a T3 below.
So when you say wireless, it's not necessarily mean wireless. Actually, you are connected, like physically connected through this fiber optic cable.
Wireless are very limited today. Wireless is very limited today. We don't have wireless when you're talking about long distance. Long distance, you can use satellite. You can use satellite, but not wireless. Wireless is actually cellular. Yeah, so you have T3.
The coverage is limited. When you say wireless, the coverage is limited.
The coverage is limited. And then there are, the coverage is limited. So then say you have satellite, for example, T3, and then you don't have this connection to your line. It can be a physical one. Move to your fiber optic, for example. Yeah, fiber optic. Actually not fiber optic, optic fiber. Yeah, it's a fiber optic fiber. Optic fiber is glass. It's glass. It's actually silicon. It is glass. But at times we cannot connect with optic fiber. What do we use? We will use we will use we can also use satellite. There are two types of satellite. We have point to point, point to multi-point. We'll cover that in the topic of networking later. Yeah, so we have this communication up to the satellite and down back to the satellite. And then see, from this point, for example, you have connect to another fiber optic, for example, here, optic fiber, another optic fiber here. So that is what they move from destination to destination. Actually, it connects the whole world. The internet connects the whole world. The whole world is connected physically or using satellite. And then here, say what we talk when you talk about 5G, and then you see stamp here. There is a band, there is a footprint. It covers a small area, just a small area, wireless, or we call it cellular. Why is it called cellular? Because it's comprised of cells. This is a cell. This is one cell. So you are here. You are within that cell. It is communicated within that cell. So this is 5G. Or 4G, 5G, 2G is here. 2G or 1G. And the first generation is a GSM. GSM. We have 5G, 2G, 5G. 3G.
On, Doctor.
Yeah.
The reason, there's actually a debate currently, kenapa Malaysia is not ready for 5G. Because remember the story of that girl yang last time masa MCO tu, she was on a tree because she couldn't get proper internet tu kan. So they're saying that Malaysia 4G pun tak wide enough coverage lagi. So that's why the government actually pushed the 5G punya initiative to 2023. Because with 5G, like Dr. cakap, they need a lot of, because the bandwidth that they're using is shorter, so you will need a lot of 5G punya cellular yang tadi dia nak cakap tu. So maknanya every lamppost, every pokok, every electric pole tu kena ada 5G punya antenna. So 5G actually going to
the footprint is small. The kawasan, the coverage is small. The coverage is small. 5G, the larger the number, from moving from 2G, 3G, 4G, 5G, the smaller become smaller by greater bandwidth. But do you require the whole bandwidth? We want to have some basic communication, unless we can connect by physical. So actually, the physical connection is much more reliable than the wireless connection. Like wireless connection is cellular connection. What is cellular connection? Cellular connection is connected using radio waves. This is radio wave.
Doctor, so does it mean that actually our line, physical line, the fiber optic line actually is faster than or equivalent to 5G already?
Yes, it's actually quite fast, very fast, because optic fiber, it the message goes through speed of light, not as as, as fast as speed of light, but it's actually light. The signal goes through light. What pass through is light. Optic fiber is actually the light actually move the laser, it's light. So it's quite fast, and then only how many strand you need, how the bandwidth that you can improve. The 5G is radio wave. Okay, does that answer you, Alia? Okay, anything, Alia, you want to say?
Yeah. Okay. Actually, Astro they have those satellite dishes, right? They are actually coming up with internet that is based on satellite. They're working on it now because we're actually working with Astro on that. So Miasat is using their punya satellite to provide internet dekat rural areas. You know how dekat rural areas everyone has Astro, but they might not have internet, right?
Yeah.
Semua rumah in rural areas ada the Astro dish outside their houses. So they're trying to provide internet via the satellite. So, but it will be affected by weather lah. Tapi at least they don't have to build towers a lot dekat all those pedalaman areas.
Why the satellite are affected by weather?
Because the satellite wave the satellite dekat angkasa kan. So that's why during rain kan our astro akan siaran terganggu.
Why?
Okay.
There is a term that for when you talk about satellite, there is a term we call line of sight. LOS, or we call it line of sight. That is the setback of satellite. We require line of sight.
Kalau hujan ataupun ada awan banyak tu, dia tak nampak. So that's where the connection is reduced.
Yes, that's right. There are two types of satellite, but we go detail later in topic of networking. There are two types of satellite. We call it point-to-point satellite and point-to-multi-point satellite. Okay, point-to-point satellite like Miasat, Palapa, Tiongsaat, Razapsat, those are point-to-point, point-to-multi-point satellite. Point-to-multi-point satellite meaning the satellite will deliver same signal to everybody. And then there is another satellite, we call it point-to-point satellite. Point-to-point satellite like Iridium, Asia Cellular Satellite, not Asia Cellular Satellite, Suraya. So this is point-to-point satellite. It's like a telephone call. So there are Earth satellite and the satellite. And then the very basic natural satellite is the moon. Yeah, so but the moon it moves around, so you can not so it's difficult for you to use. But there are two basic groups of satellite. We call it geosatellite, geosynchronous satellite. This is fixed the specific coordinate, and then we have another what we call it low Earth orbit satellite. So there are many satellites. For example, Iridium have 48 satellites, so moving around the globe. So okay. That is satellite communication. Now, when you talk about you want to use Miasat, Miasat is a point-to-multi-point satellite. Compared to say Iridium, Iridium also have ADS. When you communicate line to line, our most common line to line that we have used previously is ADSL. asynchronous digital subscriber line, and then or you can have XDSL, meaning the SDSL or something like that, or XDSL. There are systems like Suraya. Yeah, Suraya. There's a satellite called Suraya. Suraya is actually Arab. It's Sa, yeah, Suraya. Suraya, they use XDSL to deliver internet because they are point-to-point satellite. It's a P2P satellite, point-to-point satellite. And you said you want to use Miasat. Miasat is a point-to-multipoint satellite. It's point-to-multipoint. It is a broadcasting satellite, meaning everybody will have the same signal. The control is at the decoder. At the decoder. Okay. And then that this is a satellite. So when okay, referring to back to question from Habibah. Is it clear, Habibah? What is 5G? Why do we need to have cable?
Clear, Prof. Sebab hari tu there was like this one company who came and they tried to like ask us to invest in this network infrastructure. So they were explaining how they have to build like these fiber optic cables and how they have to connect the fiber optic cable to from Hong Kong, because they say that Hong Kong is acting like some sort of like transit point that connects to other parts of the world. So I was like kind of like lost with the explanation and all that. So I was like, oh, but I thought that everything travels like, you know, wirelessly. So
No.
if you say you have to build cables, then it's not wireless.
Wireless is for very limited size. Wireless is for very limited size. So you will need to connect by cable. And then there is a submarine cable actually for T1, T3. We have a submarine cable. The term is submarine cable. When you're talking about connecting to from Hong Kong and so on, there is a submarine cable. There is a submarine cable for they just put on top of the seabed. For telecommunication, it is on top of the seabed. But for electricity, normally for power, they will put 1 meter beneath the seabed. Remember, previously we have this Bakun project, Bakun in Sarawak, and then they want to send electricity back to Peninsula. So that one is power. Power, they will have to put it 1 meter beneath the seabed. But submarine for telecommunication, they will just put it on top of the seabed. Okay, any other question? Before we move on.
Between the satellite and optic cable, is it very big difference?
Satellite is very prone to because the requirement of line of sight is very prone to disturbance. But satellite is being used in the shipping industry. We have in Masat, meaning that from vessel to vessel, it's not possible for them to get connection. Then there is no radio wave, not the radio wave. There is no cellular connection, so they use satellite.
Okay, understand.
Yeah. Okay, Abiba. Alia, anything, Alia?
No, yeah, okay. Because I know the Bakun project too, under the Sarawak Hydro punya company.
Yeah. Sarawak Hydro company. What do you know about it?
We actually, my previous company actually helped them do the data connectivity because the office is in PJ, dekat Eastin tu. So they need to send back all the data daripada Sarawak Hydro tu because we were actually they faced a lot of local punya tentangan daripada the local people, because when you want to do a dam, the Bakun Dam, you actually destroy a lot of orang asli punya settlements. So people were not happy lah in Sarawak for that. But I think the Sarawak Hydro project wasn't really that successful kan. I don't know because I left the company, so I don't know what happened to the project.
Which company do you work before?
I work for IT company nama dia Zen Computer System. It was the one that worked for Sarawak Hydro lah. So Sarawak Hydro was one of our client.
Okay, the company that get a contract for Bakun was Ikran. Ikran, and then during the recession in 1997, we don't have enough fund to continue with the Bakun project. So they reduced the size of the Bakun project, and then the Bakun project was supposed to generate electricity back to the peninsula. Supposed to generate electricity in Sarawak, but to be sent back to peninsula. So that's why they have this submarine power cable. So my company was involved in the submarine power cable. So we're supposed to, it's a very huge cable, but we have to put below, 1 meter below, as compared to the telecommunication cable, which they just put on top of the seabed. But power cable, they have to be 1 meter, 1 meter quite deep also.
Yeah.
But, and then you have to put in below, and then they have line. So to come back to Tanjung Piai, to Tanjung Piai and connect back to the whole to the peninsula, because the consumers of the electricity is in peninsula, not Sarawak. When they reduce the size, so it's actually just concentrated for use in Sarawak. So they reduce, so it's not but they still proceed the project, but for Sarawak, and they were thinking of supplying it back to area in Kalimantan, not Kalimantan, Borneo, Brunei, and also Indonesia. Back then, there wasn't plan to build to move the Indonesian capital to Kalimantan back then. So now, if the Indonesian capital moves to Kalimantan, then there will be demand for electricity. Okay, any other? Yes, Alia.
No, yeah. So maknanya sekarang ni the project is ongoing, so they are only currently supplying electricity to Sarawak punya area lah. Okay, so the submarine thing tak jadi lah.
Submarine thing tak jadi sebab
budget,
and then the fund is smaller, and then they kecilkan lah, because but now they can still do big but depends on Indonesia moving their capital if they want to.
Yeah, okay.
Because capital city will require a lot of electricity, and then they cannot pull it out from Java. They will require it from Kalimantan, from the island of Borneo.
Nearer.
Kan, takkan dia nak generate a new, but I don't know, Indonesia, maybe they might want to build their own airline. The Kalimantan size is larger than Sarawak.
Yeah, itulah.
Okay. Any other question, Habibah? Okay. Jipo. Others, Najwa, Tan Chahua, Norazmin, no question?
No question.
Okay. Okay.
Doctor, is it the submarine is the issue that last time the Malaysia government and the foreigner company cannot come into the Malaysia? So the submarine, is it this one?
This one is the same. This is a cable. This is submarine cable.
Okay.
Wow. Submarine cable is cable. It is electricity cable. But a lot of these T1, T2 telecommunication cables are all submarine cable. Because when we talk about internet, the whole world is connected, physically connected. Only certain part we have this cellular, and then at certain part we have this satellite. But even in most part, actually, satellite communication for data is not very strong, except for XCDSL tried by Suraya so far. But it's still not very efficient because of the line of sight for satellite communication. Satellite communication are affected by line of sight. But nevertheless, some cable providers, especially in the US, they link it with the telephone line. They use telephone line combination with satellite. Okay, so we move back to our point here. Okay, this is the infrastructure. Okay, that's all for this topic on the basic infrastructure, and then we'll move on to database. Okay. Okay. Should we just continue, or do you need a break? You can just continue, right? We'll take a break later. So now is 11:27. Okay. Before this, before we move to database, file, record, field, and entity and attribute, I would like to draw you to look into these components, the field and the entity, and the attribute. What is the difference between entity and attribute? Then only you will understand clearly. What is an entity? What is an attribute? What is the difference between entity and attribute? Najwa, what is the difference between entity and attribute?
Entity is more like being an organization. An attribute is what the features they have, what they provide.
Okay, okay. So that is. So when you talk about entity and attribute, because you need to be very clear. Sometimes you get confused as you go along. Okay. A lot of people get confused when you talk about data because they don't understand what entity and attribute. So we say you have a man, a person. I'll try to draw a person. Okay, and then this is a person. Yeah. So this person have this is an entity. This entity have attributes. So what is their attributes? They have name, name, and then they have this ID, identity number, maybe ID, matrix number or IC number. They have address, they have date of birth, height, weight, and then some biometrics are also data. Yeah, biometrics are also attributes. Retina, thumbprint, and so on. So these are called attributes. So when you look into database, this whole thing about the entity is one record. I put in capital. It's one record. And then each attribute is called fields. So you have record for a person. And then in the record of that person, we have the fields that identify, that provide information about the person or data about the person. Name, ID, address, and so on. This is referred to as fields. So you have record and we have fields. So now you can distinguish and then you can relate between entity and records and attributes and fields. Yeah. So you move back to our slide. So in the database, when you talk about database, when you have this, the whole thing about the organization is called database. In the database, we have specific files. For example, in the marketing department, they have files. And then this file comprise of records. Records relates to the entity, right? Records relates to the entity. In the entity, we have field. So the records is relate to the entity. Yeah, and field relate to the attribute. So the field will provide the character, each word or numbers actually. It provides the attributes, characteristic, quality, describing the entity. Okay. Any questions so far? Okay, now it's clear, yeah. So clear this. Okay, so we can see here database. We have database, student database about the course, financial file, personal, and then there is the file on the course, and then they have this is a specific record. So this is a specific record, and the record they have field. Yeah, and then in the field we have this is byte and bit. Byte is this is letter I in ASCII. IS. Letter I in ASCII is 01001001. ASCII is a standard to decode letters, and then we have bit. So we have the standard is 8-bit. One byte. Okay. So now you know what is field, what is record. So field relates to the attributes. Record relates to the entity. Yeah. So this is the field. Yeah. This is the field. Course. This is one field. This is one record. In the file comprised of records. Okay. Any questions so far? Okay. I think those who have done database earlier should be easy. Okay. So previously we have this traditional file system. This traditional file system is not about the physical file, it's actually the electronic file. Still electronic file, but this electronic file are maintained separately by different departments. So we have accounting department have their own file system, electronic file system, database, and then accounting have their own, and so on. So when there are they are maintaining their files separately, so there are data redundancy, meaning that accounting department have their data, the production department have the same data, HR have the same data, so data redundancy. Data redundancy is actually what it means. It is actually same data kept by different departments. Systems. Different department or system have this the same data. So because of the cap massive data, there are prone to be data consistency. For example, we have sometimes we put it a BDUL. Yeah, for example, my name is Latif, for example, yeah. At times it can be ABD. Yeah, and sometimes with A Latif, for example. So data are inconsistent. So every department record separately because they use different program or different application or different software. So because they use different software, so it is the data is dependent on the program. Yeah, so the format of data or the type of format of data not just format, maybe the structure, format and structure of data dependent on the program or software. Same time, it causes lack of flexibility because it's difficult for you to change data from data to another data. Otherwise, it will be inconsistent. You will create more redundancy, and then there is also poor security because it will be costly to change all. When you have too many systems, too many data, it will be costly. So at the end, the security is poor, and then lack of data sharing and availability because everything is in silo. Everything is silo. You have accounting department, yeah, we have accounting department, we have production department, we have sales department, yeah, production department, which are not connected with each other. So they are not connected with each other. So they're supposed to be connected, but it is not connected with each other. So we have here, it's not connected. So lack of data sharing and availability. So this is the problems with the traditional file environment, traditional. So yeah. Okay, we will move on. So the traditional file processing you can see here is dependent on application. Relative file, we have different department, different users. So and then we have this advent of centralized data management system. With centralized data management system, we have a central database that serves many applications by centralizing data and controlling redundant data. We centralize the data and control redundant data, meaning that there are more than one data we combine, and then we call it database management system or DBMS. This database management system interface between application and physical data files. Sometimes we call it loose coupling, meaning that the application and physical data files are separated. So it separates the logical and physical views of data. So it solves the problem that we mentioned just now, in terms of redundancy. It is able to control the redundancy. It eliminates inconsistency because the data is only kept in one central database. It uncouples program and data. We call it, actually the term we call it loose coupling. Yeah, the data and program are uncoupled. And then it enables the organization to centrally manage data, and then we will have better data security. So you can put in firewall and so on to improve the data security. Okay. This is an example of loose coupling on a central database where we have the main database for human resource. We have employee ID, name, SSN, position, date hired, and so on. And then we have a database management system. This database management system will provide the suitable data records for use for specific group of people. So we have, for example, this is for uh, a department that involves with health benefit, yeah, and then this is in the department that in charge of payroll. So different unit or different group of these people or different person will have access to specific data only suitable for their need. So not everybody can see the salary, and then even for example the healthcare, maybe there is a HR unit in charge of medical will be able to see the healthcare record, but the person that in charge of payroll will be able to see the payroll record, but they cannot see other records. So it is managed by the centralized database management system, PBS, DPMS, and then the person in charge here usually we call it DBA. What is DBA? It's database administrator. We have a database administrator that manages this. So, and then one of the most prominent database management system is the relational database management system. Besides relational database management system, there are hierarchical database management system. There is no SQL. No SQL stands for not only SQL, but the most prominent, most popular database management system is the relational database management system. Relational database management system, they put data into tables. And then these tables are two-dimensional tables. So each table contains data on the entity and attributes. What are the entity? Entity is about the unit, the person, and so on. The attribute is the characteristic of the entity. So the table will have grid of column and row. The row is about the record, the field is about the attributes, or the column is about the attributes, represent the attributes. And then they have keys, two types of keys, we call it, the two types of unique keys. Two types of unique keys, we call it primary keys and foreign keys. Okay, before we move on, any question so far? So before we move on the primary key and foreign key.
Doctor, for just now the entity and the attributes, the slide, can explain again.
Okay, entity and attribute. And go back to our
the database, the slide.
We go back to the whiteboard. We go back to the whiteboard. I think better we go back to the whiteboard. Where is my whiteboard? Okay. Entity and attribute. We have records and field. Entity is the person. For example, the person. And the person have attributes. His name, ID, address, date of birth is attributes. And then the whole thing about the person is called record. And then the attributes about the person is called entity. Okay, because that's why you have to begin with this. When you move to database, you can understand more clearly. Yeah, so we move back to the slide. Okay. Anybody not clear on? Anybody else? Any question? One Jipo. Any question? Okay.
Okay.
Okay. Emmanuel. Okay.
Yeah, okay, sir.
Okay. Alia. Okay. Alia.
Okay, doctor.
Okay. Okay. Now we move into primary key and foreign key. So for relational database, because there are it is group, it is made by tables. So we have a foreign key and so every key, every table have their own primary key. Primary key is unique. This is the primary key. Yeah, not this. This is okay. This is the primary key. Primary key is unique, meaning there is no record that have the same primary key. You can look at here. Say for example, record number 1. I want to go. I want to use a box. Okay, primary. This is one record. Yeah, about one entity. This is one record. Another record. Another record. And then, but none of these records have the same supplier number. The supplier number is the primary key. Yeah. So how do you relate a supplier number to the part number? So you have supplier number here, but there are similar. For example, these and these are similar. Okay, it is unique here. It is not unique here because one supplier can provide more than one part. Yeah. So when a primary key is placed in a different table, so this is the primary key for this part. I need to clear. Okay. Okay. This is the primary key here. This is primary key. So this is called foreign key. Yeah, so this is the called foreign key. Okay, any question on foreign key and primary key?
Prof,
Is it clear?
primary key and foreign key too, is it complementary of each other or are they like separately? I mean, is it dependent or is it independent of each other?
It is independent.
Okay.
It is independent because the part number and supplier number, what does it mean? Independent, dependent. It is actually it's not it has nothing to do with each other. Only that when you relate part number with supplier number, when the primary key is placed in a different table, it is called foreign key. When when a primary key is placed in another table, because this is by table. So this is the table. This is the supplier table. This is part table. So when supplier table have their own key, part table have their own key. When a primary key for the supplier's table or any table placed in a different table, it is called foreign key. So the primary key need to be unique, but foreign key it is not unique. At the other table, in its own table, it is unique, but in another table, it is not unique. It need not be unique.
So basically, whether the data is a key field or primary field is depending on what are we looking for and how we arrange it, right?
Yes.
So basically, it's like if asking this semester which student take what module, then the student number will be the unique, will be the key field. But if we're gonna arrange it based on the module, then the module number will be the primary key and the student will be the foreign, right?
Yeah. Yeah. Something like that. Okay. Habibah, okay, Habibah?
Doctor,
Okay,
if
Prof.
like,
Number
Doctor,
one,
if
yes.
like we want to put the purple color table into the green color table, so is this the primary key? For example, let's say I'm referring to the 8259 in a green color, and then they will have a 137 and 152 in a as a. Is it will be called foreign key, or is just a what it's called? If let's say I wanted to
Okay.
update the green color.
Okay, this 135, 137. I need to use this. I need to. Okay. Wait, okay, this 137. Yeah, 137 and 852. Okay, these are primary key for this table. It goes to the 8259, 259. So it relates to 8059. 8059 is a primary key for the supplier table.
If let's say I would like to add another column in a supplier table with the part number, is it will call as a foreign key?
Yes, it is a foreign key. We'll add in the part number at the end of the supplier number. The foreign key, the primary key must be the upfront, but you can add the part number at the end of the foreign key. But it will be a foreign key, but you cannot do that in this table because will have duplication because this table is meant for suppliers only. This table is meant for part only. It doesn't fit. Yeah. Okay. Any other question? Okay, yeah, because no question, we can move on. Going. So there are these are basic operations. Basically, you don't have to remember these basic operations. There are many more operations for this structured query language. The language that we search for to call the database, to query the database is called structured query language. Yes, so it's actually structured query language. There are many more. We call it structured query language. Sometimes it's abbreviated as SQL. So SQL works similar like if you remember when we studied in school, we have this Venn diagram. It works based on the Venn diagram. So when you look at, for example, part number, we want to identify, this is the question, this is the question. Okay, you want to identify, select part number, you want to, and then also part name, the supplier number and supplier name from the database of part, from the table of part and table of supplier, where we look into supplier number and it equals to supplier number and part number 137 or part number 150. Okay, the key is what you call it, you have a supplier number. You want to have a supplier number and you need to have a part number 137 or part number 150. What is the difference between N and O? The keyword is here N and O. What is the difference between N and O? Okay, I'll move into, I think they will get confused if you look here. We'll use whiteboard. We'll clear this. We remember we have our Venn diagram A, B, when we talk about A and B, A and B is A. Which one is A and B? And then the other one is A or B. Okay. Give me the answer. This is your Venn diagram you learn in primary school. A and B. Which is A and B? Which block is A and B?
C.
C. Which block is A or B?
A and B.
A.
A or B.
B. Okay.
Yeah.
Hold on, I got. Hello, Mercy. I last class nanti. Yeah. Okay, the guy called. You was. So when you look at here, okay, this is A on B, A and B. So we learned this during our school, right? Okay, so when you look at the, go back to our slideshow. So when you talk about A, part number, and this is supplier number, and part number 137 or 150, meaning that it is both. So this is the answer. The answer is here. The part number, supplier name, and then it is 137 or 150, meaning this is 137 and 150. So you look into part number and supplier number, we look into combination of 137 and 150. So we have here 137 and 150. So this is 137. Okay, this is 137. 150. So this is 8259, 8263, 8259, and 8263. So this is the answer. Yeah. Okay. Any questions so far? Can follow? But this is just an example. I usually don't put this detail in, just put this in examination. Okay, but as long as you can see the relationship is based on the Boolean, yeah, Boolean. It's called Boolean, yeah. The term is Boolean. Yeah, and or it's called Boolean. Okay. Habibah, okay. Najwa.
Okay, Prof.
Okay, Najwa, okay. Alia, okay.
Okay.
Okay, so this is Boolean, eh? Okay, then we move on. Capabilities of data management, the database management system. We have this data definition capability. We can define your data. We have data dictionary where you define the specific attributes, the specific so that you it can be spelled out, and then so it help you to manage your data. It has this query and reporting system. Like I said, it is the structured query language. And then they have this many report generation capabilities. For example, Microsoft Access have this report generation capability. This is Microsoft Access. And then this is example of the query you made just now. And then there is a relationship here from one part number to supplier number. We call it entity relationship. We call it referential integrity. Referential integrity. We call it referential. Referential integrity. Referential integrity, we have many to one, one to many. This is many to one, for example, many to one. This is an infinite logo. Infinite sign is meant for many. One is supplier, meaning that One supplier produce many parts. So we have many to one, many to many, one to one. Yeah. And then when you design database, you start with conceptual design compared with the physical design. We do normalization to break up the data into groups so that we don't have too many to many. So you can have many to one, one to many, so it's easier to build. So we use the referential integrity to show relationship between one data to one table to another table, referential integrity. So we build an entity relationship diagram, entity relationship diagram to model the system so that we can provide the best service. So entity relationship diagram is there is no example here for entity. This is entity relationship diagram example here, where suppliers provide many parts. This is one this is crow model, crow form. So this is many. One supplier provides many parts, or the other way around. Many parts are supplied by one supplier. You look at the bottom, and then we have one part is ordered by many line item, or the other way around. We have many line item contains one part, and then here is many. The symbol here is many. Many line item belongs to one order, or one order includes many items. So how do you read it? You look into the symbol that we have here. This is one, this is many, this is one, this is many, this is many, and this is one. This is our entity relationship diagram. And then this component here between one to many, one is called the differential integrity. Yeah, so this is differential integrity. So when we have this differential integrity, it will build up towards the entity relationship diagram, ERD. When you have this ERD, you can chart the diagram so that each one of these is a table. You have table for order, table for line item, and these are tables. So you can use the structured query language to query in order to extract database from the table. Yeah, so you can normalize it so that this is normalized table, so you don't have many to many. So we have, this is the key, yeah, primary key, and then but if you put say part quantity, if you put say supplier number at the end of the or the supplier number at the end of the, if you add in the table here an attribute or a field here, you put in a field here, and then you move this here. So this will be a, okay, this is a primary key. Whereas this will be the foreign key. Yeah, so this one is a primary key. Okay, any question? Okay, no problem. I think that should be okay. If you don't understand, just ask me. Okay, this is relationship, but not all database are relational database. There are also non-relational database and databases in the cloud. Non-relational database are also called NoSQL. It stands for not only SQL. Yeah, not only structured query language. It is a more flexible data model. Data sets are stored across distributed machine. We have federated database. We have federated. We call it federated. And then it's easier to scale because we don't have tables, so it's easier to scale. It can handle large volumes of structured and unstructured data. So when you talk about unstructured data, so it's easier to handle big data because most of big data are unstructured. 85% of big data are unstructured. And so you can handle big data. Example of these are the most Hadoop. They have their own map. I don't remember the name, but one form famous one is Mongo DB is and you know SQL data. And then you also have database in the cloud, for example, like Amazon Relational Database, Microsoft SQL Azure, and other private clouds. Okay, and then big data, challenges of big data. What is big data? Big data are data outside there, massive. We have multiple V, we have volume, we have velocity, yeah, another V, yeah, volume, velocity, and variety. And then the volumes are too great, petabyte, exabytes. It can have more patterns, require new tools and technologies to manage this database because 85% of the database are unstructured. So including web traffic, social media, sensors from your IoT, yeah, Internet of Things. There is we will use this is some tools that we use for this that SQL database. We have Hadoop, MapReduce, HBase. We use this for our for big data. This is meant for big data. Yeah, for big data. Big data analytics. Yeah, big data analytics. Okay. Go back to business intelligence infrastructure. Because before I move to business intelligence, any question? Okay. When you we have at Putra Business School, we offer several electives. One of them is business intelligence and analytics system. We also have financial technology and knowledge management system, and then we have digital business and entrepreneurship. Okay, and these are electives that you can take later part in your course. But I'm not sure whether they will continue to have this MIS as, but you in your trimester, your batch or your cohort, your cohort, MIS is a core subject, but in the later MIS might not be a core subject. But if you want to take other courses, electives such as this business intelligence, so it's better that you have taken MIS first, because otherwise you will lose track, because you will straight away do data mining, business intelligence, when you don't have basic, it's very difficult for you to follow. What is business intelligence? Business intelligence is actually an array of tools to obtain information from separate systems and also from big data, and then to provide reporting. Yeah, so descriptive reporting. So we have different levels of business intelligence, business reporting, business intelligence. I will put up in the whiteboard. Okay, I will clear this. So we have different. We have descriptive analytics. We have predictive analytics. And then we have the third one, which is the prescriptive analytics. when you have data, and then you provide this, when you provide description of the past data, yeah, this is description of the past data. Yeah, from the past data, with reference of the from the past data, so you provide description. You provide description. It's called descriptive analytics. So, but this part is usually referred to as business intelligence. Commonly called business intelligence, but there are also people call the other as business intelligence as well. Okay, and then we have this is the use infer the future to, so you can use the past data to infer or predict present future situation. Yeah. This one is to what do you call it? To recommend action. Or decision. Recommend and share decision. So, okay, for this part, I usually refer to as business analytics. But there are also people who call this as analytics. Yeah, there are also people who can also call as business analytics. Sometimes it is interchangeable. And then there are also people who call this as business intelligence. That's why sometimes when you read books or references, you can get confusion, because when you buy a book on business intelligence, it includes business analytics. When you buy business analytics, it includes business intelligence. But basically, business intelligence came first. I think don't recall the number, the years. Then they target to do descriptive analytics, statistics, and so on, just to look into the past data, provide description of the past data, and then they begin to use to do data mining. Here we use data mining. From data mining, we are able to do predictive analytics. To do data mining, we are able to do predictive analytics. And then from here, we can do simulation and optimization. So we can do descriptive analytics. So you can simulate, and then you can provide decision or recommendation. Okay. Any question? Okay. Okay. We go back to our slide. So in order to do that, we kept the database into a data warehouse. Data warehouse is a large storage where it stores the current and historical data from many core operational transaction systems. Where does you get the data? You get the data from TPS, transaction processing system, as well as when that you will process using MIS, yeah, and so on. And then you consolidate and standardize information, yeah, for use across enterprise. But you cannot, data cannot be altered, meaning that it is non-volatile. The term is non-volatile. I need to have this text. Non-volatile meaning that the data cannot be changed. Example, can accounting data be changed? Can Guan Jipu?
Accountant can change.
How do you change accounting data?
You know, the change the data inside how they arrange.
Who are you an accounting person?
Emmanuel is, I'm not.
Yeah, no. Okay. Let's see. Anybody from accounting? Accounting background?
Me.
Huh? Okay.
I'm from.
Okay. Can accounting data be changed?
Um. We can change if. I don't think so. Cannot change because if you want, because it's from it's there from an original data. So if we want to, like say you want to do the creative account, so we need to change like every aspect of details.
Okay, if there is an error, if there is an error, can you change the data? You have erroneously keyed in the wrong number. And then it has been posted. It has been posted.
If it has been posted, then we need to record another data.
Yeah, accounting data cannot be changed. If you, it is illegal actually. It's illegal to change electronic accounting data. This is what we call by non-volatile. Data cannot be changed. So data in the warehouse cannot be changed. It cannot be altered. It is called non-volatile. So example is like accounting data, because I come from accounting background as well. In order to change an accounting data, how do you change accounting data? You need to write another set of data. You need to write another entry. We call it reversal entry. Sometimes we do reversal entry. Remember reversal entry? We're doing accounting. We have posted, for example, to the wrong accounts, and then you have to reverse it. So you will post another entry, another double entry to reverse it out, and then post it into another entry. That is called reversal entry. But the main data cannot be changed. So it is being recorded. So same goes to data warehouse. It cannot be changed. So once it is there, it is always there, and then you can reverse it out if you want to. So this data warehouse will provide analysis and reporting tools. So you have tools inside it. So we cover details in this in business intelligence and analytics system. Yeah, we have that course. And then besides data warehouse, we have data mart. Data mart is specific to a specific department or functional area, so that you don't have to process the whole database in the data warehouse. You can use a small unit of data that is specific for a single subject. Yeah, for a line of business. For example, you have a project, you have data mart for that project, or you have, for example, finance, you have a data mart for your finance department, or production, you have a data mart for the production department. So you have, and then it is dependent on the data warehouse where you can fetch. There are two forms of data marts. Actually, there is independent data mart and dependent data mart. But most data mart that tie up to the data warehouse is a dependent data mart, meaning that it fetch data from the data warehouse, put into data mart, so you can analyze the data in the data mart. Okay, besides that, we have systems like Hadoop. This is targeted for big data. We have key services like Hadoop. I need to clear this. Hadoop distributed file system, data storage, MapReduce, and HBase, which is no SQL database. Business intelligence also do in-memory computing. It used in big data analytics. Instead of doing processing it and pulling data from the secondary storage, it puts everything in the RAM, random access memory, and then it's processed in the random access memory, so it is faster. So it can reduce the processing time, and then but require optimization of hardware. So and then it what your business intelligence platform also require infrastructure also require analytic platforms. So it is a high-speed platform that use both non-relational and relational database management system or the relational tools optimized for to handling large data sets. So we have Hadoop cluster here to handle with your big data that comes in through external data, web data, or audio video which are unstructured, or machine data coming from your IoT, Internet of Things. And then you have historical data and operational data. And then directly to the Hadoop cluster to do the analytic platform. Or you can take from the operational database, your TPS. You have a TPS here, transaction processing system. And then you will do extract, transform, and load into your data warehouse, and then put into your data mart. So you can have casual user who can query and then produce report and monitor your dashboard, and also power users who can do data mining. You can do online analytical processing. Yeah. At this level, at this data warehouse, you can also use we call it based on the TPS. You can also do what we call OLTP, online transaction processing. But here we can also do online analytical processing. Online analytical processing is slower. It's not as fast as OLTP. But OLTP is targeted for descriptive analytics. But OLTP you can do for predictive and prescriptive analytics. Yeah, so for OLTP, you can use it for descriptive analysis. Okay. Any questions so far? What time is it? 12:24.
Rob, I have a question. Is
Yeah.
data warehouse the same as cloud storage?
Data warehouse and cloud storage, two different
Is
things.
it the same thing? Two different
So
things. How are they different?
data warehouse can also be in the cloud. You can have a private cloud. You create data warehouse in the cloud, a private cloud. The cloud is actually just a connectivity. Cloud is just connectivity. It is over the internet. As long as it is over the internet, it can be a cloud, called a cloud, and then you have a cloud management software. But it is not in the cloud. It is physical. The name is cloud because you are connected over the web. So if the data warehouse, it is connected over the web, you can also call it cloud.
So meaning to say an organization can have their own server that acts as the data warehouse.
Can.
Doctor, I have a question. How about blockchain? Is blockchain can consider a part of a form of a data warehouse?
No. Blockchain is a chain of data. Blockchain is a chain of data. The data can be in your data warehouse. It can be in a different data.
So it's a form of secure data.
It is a form of secure data. It is a form of linking the data. Okay, I'll share you some brief, very brief blockchain. So we have data here. We have see we have data here, database. You have a database here, database here, database. database, database. It can be many more. Can be hundreds of data. Then you have data here. You have data here. You have data here. You have data here. So they are chained, meaning that they are linked to each other. Okay. One thing when about data, when you send your data, yeah, when you send your data, the main data will move from point, say if this is A. The original record, the main record will move from A to B to C to D. But the record will be left, some of the record will be left in A, but the original data will move from A to B to C to D, meaning it can move until the data is here. So the data is now here, but the main is here. Sometimes we call it distributed ledger. Distributed ledger. So you distribute the ledger. So this is what we call data blockchain. It is block and then it is chain. So when you make alteration here, so you want to make alteration here. Say you make alteration here. Say you want to make alteration. If you want to make alteration here, so you can see this data is not similar anymore. Data D, data C, data B, data, because this is alteration anymore. So because there is chain, so it will inform here that there is alteration. They will tell here that here, here, that there is alteration here. We call it tampering. Because it is linked. So you tell here, there is a tampering of the data. Because it is linked, yeah. So you can detect that there is a tampering of data because there is an alteration at this point. That is blockchain, or we call it distributed ledger. It is a chain of data. So it is not data warehouse. It can be in, this can be in one data warehouse. Yeah, so this can be in one data. Okay, here. This can be in one data warehouse, but this may be in different data warehouse. So it has nothing to do with data warehouse actually. It's about linking the data. Okay. Start the now. Let's see how many slides we have more. Analytical tools. Okay, we just finish it off. Not many more. So when you have, there are analytical tools that you can use in your business analytics. You can consolidate, you can analyze, you can provide access to various types of data. You can do multi-dimensional data analysis. Multi-dimensional data analysis is breaking it into cubes. This is an example of the cubes. So instead of only row and column, you can have X, Y, Z. Yeah? Instead of X and Y, you have Z. So you have actual projected. So and then you can have many cubes, not just one cube. You can have many cubes. So that is what we call multi-dimensional data analysis or online analytical processing. And then we can also do data mining. Example data mining, we can do associationship. Yeah, we can do associationship, association. We can do clustering. We can do sequencing.
Doktor, quick question pasal yang data mining of cryptocurrency tu macam mana?
Cryptocurrency is the application, is a product.
Kan dia orang kata they mine the Bitcoin.
Oh, mining data. Itu bukan data mining.
Oh, okay, lain.
Itu lain. Is mining data. Mining data ni dia sebenarnya, okay. Ya sebenarnya I ingat nak berhenti sini dulu lah, sebab kalau I move on, I rushing nanti, I need to tell you about the association and so on. Okay, I'll move on to your data mining, just to ada a few minutes lagi, cerita sikit ya. I'll stop here. Analytical tools we will continue next class, okay? Because otherwise, if I rush and then you don't understand, and then not good as well, not good also. So, okay, when you talk about the crypto mining, crypto mining is actually, okay, when you, I'll go back to just now, okay, I need to go back to the whiteboard. Okay, this is the distributed ledger for this blockchain. Blockchain is a technology. But the product for this technology, one of the product for this technology is cryptocurrency. Cryptocurrency. So can you send currency from A to B to C to D? The currency moves, but the data doesn't move. Data still there, but the currency moves. For example, if you send email today, I send email to say Alia, I still have the record. But if I send currency to Alia, I don't have the currency anymore. I only have the record. I don't have the currency anymore. So that's the difference between blockchain and so because when you send something, you don't have that set anymore. It is moved to the recipient. So that is blockchain. So that is why it can use to do cryptocurrency. When I pay something, I don't have that money anymore. The money moves. If I pay something, I still have that money. So the money will be expand. I still have that money, but I give to Bonji, for example. And then you steal the money, I also have money. Cannot. I give you money, I don't have the money anymore. You have the money. That is how cryptocurrency works. But I keep the record. The record is still with me. So so in the chain, any changes or tampering on the changes, everybody can see. But the problem with cryptocurrency is there is no verification. There is no validation. There is no specific authority to regulate. There is no regulation. When there is no regulation, so anything can happen. Because when you deal with our normal currency, there is an issuance. For example, the central bank. Central bank is the authorized issuance of the currency. So they keep control, they monitor and so on. But for cryptocurrency, no one monitor. So they have created a system of monitoring. This system of monitoring is to validate the currency. So how do you validate the currency? They will do what you call guess game. They will do a guess game, a guess. So this guess game is what we call mining. You guess. You go to data A, check whether there is alteration or not. If you get the alteration, the currency issuance will pay money to you. You are guessing which transaction have tampering. Which one got tampering? So you have to, it's actually guessing game. So you need machine computer to guess. So they don't do manual guessing. It's actually automated guessing. They just machine just tembak, and then kalau if you get the one that is tempered, you will get paid. If there is no tampering, you don't get paid. So you will do a lot of guessing to detect tampering. to detect changes. That is how the currency is validated, so that nobody can temper the currency, because somebody else will be mining and checking who made any tampering. That is called mining. You asked that question just now, Alia. Oh,
Yeah.
yes. Now you dah clear?
Ya, tapi confused lah kan sebab yang pasal Bitcoin tu macam orang kata kena beli Bitcoin because there's only certain limit of Bitcoin in the world. And then siapa yang jumpa the first Bitcoin tu semua like it's
No, actually the Bitcoin is anybody can issue the Bitcoin. Anybody can issue their own currency. That is why it is for Islam actually it is not permissible. Dipanggil gharar. Gharar meaning that there is uncertainty because anybody can issue the currency and then we do not know the currency is stable or not, and then if the person died, but the person that issued the currency, everything is gone, the money is gone. So
that's
that
why
is
China
gharar.
approve That's why China approve and Bitcoin currency.
No country ever approved currency ever approved, but there are transactions done using Bitcoin. But Bitcoin has its own checking. It has its own checking method of checking to make sure that actually the tampering doesn't happen. To make sure that the tampering doesn't happen. That is called mining. The check.
So basically, they say Bitcoin mining is basically they have set up a computer to find anyone that is tampering with the system.
Yes.
And how a Bitcoin is generated.
Yes.
Someone else is tampering.
Yes. So if you find people tampering, they pay you.
Then what happened to the person who tamper?
They will. That is how they will go back to the original record. They will revert back to the original record. It's actually to prevent tampering, because there is a calculation for this what do you call it, re-evaluation or increase in value of the tampering, but I think 10% goes to the checking. Meaning if you so the value will increase, but the 10% of it goes to the person who does the checking. But if the checking is done using a guessing game, that is called mining. We do not know who tamper. So we just guess. So we create a machine to create guess it. There is a machine to do that. Okay. That is for any other question? Any other question? We are 12:40 now. Now it's 12:40. Any other question? We will continue in data analytics the other week. Next week. Do we have class next week? Yes, we have class next week, right?
Yes.
Today is 31st. We have class next week. Next week we'll continue with the big analytics, and we move into networking. We'll go more into satellite, cellular.
Doctor, I have a question. My question is good. In terms of big data, right? Write up a data or write up the language system. They obviously use a different language system. Is that if let's say a programmer or a program have been run for quite some times, then they want to upgrade the data or the server or the cloud, right? Is there a need of a same programming language, or is it okay to have a different programming language or data language?
Okay, this has nothing to do with big data. Actually, it's just data warehouse and data. When you talk about big data, there will be many different languages, and then you need to have some form of natural language processing or middleware to convert data to a language that can be processable for the specific machine that you have, specific language that you run in your data warehouse. But if you currently or previously have the data, we call it legacy data. Legacy data, some previous systems they don't comply to the standard format. They have their own format of database. They don't follow specific like W3C or anything. They create their own. They don't follow XML or anything. So in order for when you can buy your new system, if you buy a new system, you need to convert that data to the new system. So either you for your data warehouse, you can do extract, transform, and load. We call it ETL. There is several software that can help you to do the ETL, extract, transform, and load, or you can also get a middleware. There are also middleware that help you to transform from the old data to the main data. But it is best that you want to buy system, try to get a system that comply with an open standard. So that when you move, you change hardware or you change your platform, you can still use of the data, and then you don't have to incur cost. Because when you buy ETL, there is cost. When you want to transform the data, there is cost. When you want to develop, design or develop a middleware or buy a middleware, there is cost to you. Okay. Does that answer you?
Perfectly. Another question, Doctor.
Yes.
Is it better to use a server or a cloud, or use a hybrid?
Okay, it depends on the security of the data, the what you call it, sensitivity of the data. If the data is government data, most of the time they don't put in cloud unless it is a private cloud, meaning they develop the cloud by Mampu or anything. So it's reside within the country. But if you apply, if you use Amazon, for example, Amazon put the data in, they have two zone area, they call it zone area. One in Singapore and maybe one in India or one in Hong Kong. If the system in Hong Kong is down or in Korea is down, it will move into India and so on. But at times, certain data information is sensitive. So you don't want to put your data in a foreign country, because the law of the land state that if the data is in a foreign country, you will have the government of the land will have access to that data. For example, if you have a case, for example, with Singapore, say in the court cases in the international court, international court, for example, and then we don't want to have our data there because and then the government will have access to that data. So that is why we require data to reside within the country, within Malaysia. But you put into cloud, for example, our My Sejahtera data, I'm not sure where it is placed. If it is placed abroad, then our record are also all accessible to some other people. This is not technical. This is legal. This is legal requirement. The legal law of the land state that. So they cannot say cannot, because otherwise you can move your data elsewhere. So this is legal issue. So whether you want to put cloud or you want to, and then say cloud at times, cloud are also expensive when you look into exchange rate. But if you use a local cloud and it is cheaper actually, or the TCO, total cost of ownership, having a local cloud is much lower than building your own server or data warehouse, because the entry point is low. You don't have to buy server that costs maybe 100,000 or even 50, 40,000, 50 or 75,000. You don't have to buy. You can just pay per use, meaning that when you want to use, you pay. So you can immediately start. There is no gestation period. So you want to use, you just go to the data center. You can immediately set up in a few. I mean, within the day, you can have your database is fast, and then they have a proper what do you call it, management system or dashboard that you can use. So you can up and running very short of time at a very low cost. So there are pro and cons. You look at it. What do you need?
Oh, doctor, that means you're saying that actually Malaysia does have provider of cloud service that their server is in Malaysia.
Yes, there are several cloud providers in Cyberjaya and in other areas as well.
If I may add on, Mampu has recently approved 4 major cloud vendors. There adalah AWS is already approved now, Microsoft Azure, TM, as well as Google. So they've already, the government have already approved these 4 main public cloud players. Tapi I agree also dengan Doctor, meaning that only the non-sensitive data is put on cloud, on public cloud. Yang lain semua it's either on premise ataupun they do it in their own virtual private cloud.
So it's called hybrid cloud.
Yeah.
Hybrid cloud meaning that you have cloud and then you segregate your private cloud and public cloud. Actually, they can put some data in telecom. Telecom also have their cloud. For private cloud, they don't have to put it in Mampu. They can put in Telecom Malaysia. Or we used to have Jaring, but Jaring is no more. And then the sensitive, non-sensitive, the sensitive data lah. The non-sensitive data we can still put in Amazon. We cannot control Amazon where they want to, but we can put it in your SLA. But if there's no way, we're going to check where they move the data. But because that is operational. Okay, any other
Okay,
questions?
just to add on, I mean just to add another question, right? So regarding this, what we call this, the data, the privacy data on the law, right? So is it okay to put the data in the cloud on this law or not?
It's actually it's up to you. The law do only state that if you put in your data in Malaysia, so the law of Malaysia is binding. If you put data in Singapore, the law of Singapore is binding. If you put the data in US, the law of Singapore of the US is binding. So like Alia mentioned just now, it depends on which data that you want to put in a foreign country and then which data you want to put in local. Does that answer you, Shaiful?
Yes, correct. Thank you very much, Doctor.
Okay.
So basically, is the privacy policy is depend on the country. For example, it's just like why people put money in Switzerland because they have a policy that the money there is nobody can check. Is
Yeah.
that the reason?
Yeah, same thing. Because every country have their own law, so it complies with the law of the country, that specific country. So it's up to you. Okay, any other question? Or you want to add, Najwa, Habibah, Norazmin?
Actually, Doctor, I just want to add, I went into this server data or cloud computing server place, which is the high-tech padu punya, dan beberapa orang punya lah, because I wanted to audit the database of certain government agencies, which is quite big, and I cannot reveal it now. And when I enter to that server place, there's a lot of procedure there to enter, a lot of what people call checking system security, so many things. And when I go into the particular server placed, and then the name of the particular location is not as what the agency name. The name all is with is a different name with different codes. And to you to enter, you must have a specific barcode. And there's a few securities set to go there. I mean, when come back to the question just now, to you to choose whether you want to give it to outsource to a what, it's also back to basic one where you have, let's say you want to rent a house, what are the things that you want to, what are the security that you want? So that kind of basic things apply to this cloud computing. but it's depend on the privacy. And when come to government one, we also apply the government Data Protection Act to be placed in together, so that it also is also governed by the act. So
okay. Yeah, because we have a what we call server farm. We have a server farm. We have a data center or server farm. So this server farm may be ABC company. And then this ABC company, it has a data center, and then it actually it rent out racks. It rent out racks. And then in the racks, we have several racks. We have maybe hundreds of racks. In the racks, one of the racks may be occupied by DEF company. And then this DEF company provide cloud service to say another company, the cloud service. So the cloud service provider, the cloud service say subscriber, say that they subscribing from DEF. So when they go to, so it is DEF. But DEF actually only what they call rent a rack. They don't have the whole data center. So when you go to the data center, oh, it belongs to ABC company. But there is a agreement between DEF and ABC. So the person that can come to the ABC data center are only staff authorized by DEF. So there is a physical security when you come in. There is a physical security check and so on. But at the end, when you go in, oh, there it is so that is the difference between data center and then the rack. And then where is the data warehouse? Where is the data warehouse? Alia, where is the data warehouse, Alia? Data warehouse is in the server. It's in one of the rack. It's just in the server in one of the rack. So there you can see where is the data warehouse. It's not a big warehouse that you can imagine like you go for Tesco, you have a warehouse. No, it's not a warehouse. The data warehouse is it's just an installation in the server in one of the rack, and the rack belongs is rented by DEF company, and DEF is renting the rack from ABC company. ABC company runs a data center, and then it can be amongst the many data center in one server farm. And is it true, Emmanuel?
yes, sir. Yes.
That is how we work. Okay, any other question or any other comment that you want to share? Otherwise, we can adjourn for today. We'll meet again next week. Okay, thank you very much. Assalamualaikum.
Thank you, Doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, Doctor.
Um,